So this is going to be a talk about JSR-305, which I'm the lead on, annotations for software defect detection. And this is going to be both a deep dive, followed by a discussion. And yes, I have pimped my keynote. This is keynote 808. But anyway, so this is a straw man proposal. This is not a done deal. I am very actively interested in feedback about what I'm proposing. And I'm going to present a lot of details, things that are far more detailed than somebody who would be a typical user of this system would actually use. So I'm actively seeking feedback. I've got too many slides, so I don't want to get into any long debates during the discussion, but I've actually got a conference room reserved downstairs for an hour and a half after the talk, and would love to entertain all the discussions we can there, and you guys can, I'm still at Google for another week and a half, and you guys can plug me. So one thing, it's a JSR through the Java community process. David Morgenthaler is Google's representative on this JSR, and so Google is giving comments. He's part of the expert group, and hopefully this will actually turn out something. Okay, so annotation. So we've already got static analysis tools. Static analysis tools can do interprocedural analysis to find some bugs that cross procedure boundaries. But annotations are really helpful. They express design decisions that may be implicit or described in the documentation, but not easily available to tools. All right. So here's some code. We need to figure out where the bug is. Right? So if spec's not equal to null, we add spec to f fragments, and then if spec is complete, we add spec to f preferences. Well, you can't really see what the bug is here. Now, if you look at the body of is complete, you can figure out that if spec is null here, then when we call is complete, we're going to get a null pointer exception. So we found a bug, but we haven't done one of the most important things when you find a bug: figure out who we ask to fix it. Right? Is the problem with this code that is complete should have handled null by returning false or something? Or is it the case that it was wrong to pass null into is complete? A static analysis tool can't tell you that. It can't tell you who to blame. Right? And that's important. Right? So a lot of bugs can only be either identified or localized to, who's responsible for fixing this, if you actually know something about what the code's supposed to do. Right? And annotations are well suited to this. And one of the most compelling examples is to have an annotation called non-null, which says that this parameter is non-null. Now, I'm going to assume that most people know what annotations are in Java. There was something that was added to the Java programming language in Java 5 that allows you to define new annotations, and then you can put these on things such as method parameters and so forth. And then whatever tool you use to then look at the code can assign its own meaning to those annotations. Okay. So annotations for nullness, it's a great idea, and so great that at least 2 different tools defined their own annotations for non-null. And they actually and not only did they use different package names for where the non-null annotation resided, but they actually had slightly different semantics. Right? And as hard as it is to convince somebody to use annotations in their code, it's really impossible to get them to put in 2 sets of annotations into their code. And so one of the things that was very clear that we had to do is if we wanted to have a non-null annotation, we couldn't have each tool vendor having their own non-null annotation. We had to come at least to an agreement with a common name, common package name, and what its semantics are. Right? And so that was one of the things, and I'm actually sort of pushing 305 to include a little bit more than just coming to an agreement on standard names. So 305 is intended to be compatible with any version of Java that supports annotations. It doesn't require any syntactic changes. We're not allowing ourselves to require any syntactic changes. So if you're running in Java 5, then we'll be able to download a jar file that contains the new annotation names, compile it, get the stuff, and then but Java 5 won't interpret the annotations, but any tools you happen to use, like FindBugs or IntelliJ, will be able to interpret the annotations. Right? And we hope to have usable drafts and a preliminary tool support out by the end of the summer, which I just checked gives us till September 23rd. There's a separate JSR annotations on Java types, which is designed to allow you to put annotations in more places. That targets Java 7. It interacts with this JSR, but we're not dependent upon it. OK. So nullness is the great motivating example. It's the one that you say, yes, I want an annotation. If you can sell an annotation for anything, you can sell an annotation for nullness. Right? So most method parameters are expected to be non-null, always non-null. There are some research papers that support this. It's not always documented in the Java doc. We've had a number of cases where we say, oh, this looks like our tool found a bug. Let me look at the method spec to figure out whether or not this method is supposed to handle a null parameter. And it's often very hard to figure out whether or not the method is supposed to handle it. And so what do we want to do? We want to document parameters, return values, and fields that should always be non-null. And then if you've declared a method parameter as non-null, then if you see code that is passing, that could pass a null value to that parameter, you want to generate a warning. It would also be nice to have annotations about which things should not be presumed to be non-null. So for example, the equals method, that's supposed to handle null and handle it by returning false, as opposed to handle it by throwing null pointer exception. Right? And so not only is this not a non-null parameter, it's a parameter where you need to expect null. Right? And so in particular, because of what we know about equals, if you see an implementation of equals that immediately dereferences the parameter that's passed to it, we want to generate a warning. OK, so we have non-null, and then we have expect null or something. I'm not quite sure the name. But I think we may actually need to have sort of three cases that's useful to say three different things about nullness. Because what about map.get, the return value of it? Right? So it returns null if the key is not found. Right? And also returns null if the key is in there, but the value associated with it was null. So the return value can't be non-null. Right? But there are, and I've gone through and done this stuff in like student programming projects and so forth. There are lots of places where you call get, and you know that there damn well better be a non-null key value in it for this particular key, because you know it's already in the map. And if you forced programmers to say, every time you call map.get, you better put in an explicit null check, I think the programmers will hate you. And we don't want programmers to hate us, right? So I think what you want is to basically be able to say one of three things about, for example, a method return value with regards to nullness. One is that this thing is guaranteed to be non-null. One, that null is definitely a value that you have to worry about when interacting with this method. And the other one that just says, you know, this is too complicated to boil down to like a one-word phrase. Maybe it depends on the calling context. Maybe it depends on the method parameters. Maybe it depends on state. But anyway, well, and I'll talk into some of these. I'd love better name suggestions if anybody comes up with them. I'm not.
Need a name for that. Isn't that the default?
We'll come back to that.
Okay.
Right. Question is, do we need a name for unknown nullness? And yeah, we do. And I'll explain to that. Nullable might work for one of these. But I don't know. So I won't debate names at the moment. OK. So non-null, little subtle thing for fields that it has to be interpreted as what the field should have after the object is fully constructed, because fields are obviously null initially. And the tool will try to generate a warning if they see a possibly null value being used in a place where something that's been marked as non-null is required. Same thing as if they see a dereference of a possibly null value.
So is the system going to try and distinguish initialized objects from not fully initialized objects?
I mean, the question is, will the system try to distinguish them? I mean, to some extent, this is all up to the tools, right? This is just indicating your intention. And if a tool wants to get more sophisticated and figure out that, oh, this object is still in the still in the process of being initialized, thus, even though its field is marked as non-null, it might actually be null. That's up to the tool. It's not part of the spec.
Is it the intent that these annotations provide a tool with enough information to understand that?
There's never enough information. I mean, the thing is, the intent is to provide useful information, and it's not complete information. Right? You can't provide complete information without getting into a page of spec for every page of code. Okay, so null feasible means the code should worry that this value might be null. For example, the argument to equals. And tools, if you see a place where you invoke a method that returns a value that's marked as null feasible and you immediately dereference that, you'll want the tool to generate a warning. Right? And then unknown nullness, which is the same as having no annotation, as Neil pointed out. The reason I think we actually need to be able to do this with an annotation is because we're going to wind up introducing something that I think we need, which is default annotations, that you can say for a class or a package, I want my method parameters to be treated as non-null by default. But you might, in a couple of cases, say, no, but for this method parameter, I want it to be treated as though I don't know whether or not, I don't know anything about the nullness of this parameter. Right? So we need to be able to get back to the original state. And this means that it's null under some circumstance, might vary in the subtypes, depend on other parameters or state. Interprocedural analysis might give us better information. If something is marked as non-null, if something is marked as unknown nullness, that doesn't prevent us from doing interprocedural analysis to find a potential error. It just means there's been no statement of design intent about the nullness of this element. Okay. So actually having tried to apply this, if you mark that some value could return null, it tends to require work. It's sort of like marking something as const, right? I mean, this is semi-fun. You go to a method and say, oh, this method could return null. So you mark it as null feasible. And then you find out, oh, well, this method returns the value of that method. So you have to go mark that one. You get this whole propagation that's a little bit similar to what happens when you use const in C++. So I'm just saying this is why I'm convinced that you need this concept of sometimes you just want to say, I don't want to state any clear guidelines about whether or not this value is null. I just want to leave it as unknown. Okay?
But there's a difference. Const is in the compiler.
Right.
And these annotations are used.
But it's still a matter of once you apply an annotation of null feasible to something, you frequently have to go through several iterations of applying additional annotations or null checks in order to get rid of all the warnings out of your code. We can take short things. I don't want to get in any multi-minute long discussions. Oh. Sorry, what? They don't? Oh, yes, repeat the questions. OK, fine. OK. So nullness is the great motivating example. And I could talk about all sorts of various other ones that we would want to do. But actually, a lot of these form a part of basically doing a type qualifier. A way of defining additional type constraints on top of the existing Java type system. Right? Gilad Bracha has talked about pluggable type systems, which has a lot of similarities with what I want to talk about. And rather than talking about the 3 or 5 or 6 other type qualifiers that the JSR might provide, I think the most interesting thing is that we're going to provide a general framework that will allow anybody to define type qualifiers that can be interpreted by tools. OK. So actually, I want to get to one more example before I generalize. So non-negative, right? There are a lot of methods that require non-negative parameters. Do we need positive? Maybe. Non-zero, questionable, power of 2, I can conceive of it. Prime, I think we're stretching, right? But let's just consider non-negative for the moment. If we want to have non-negative, we also want to be able to talk about something that's signed, something, a value that could be either positive or negative, or 0, right? So for example, hash code and random.nextInt return something that's signed. Right? Unknown sign would be similar to unknown nullness. So this is this idea that with nullness we had non-null, worry about it being null, and I'm not going to tell you. And with signed, we have non-negative, worry about it being negative, and I'm not going to tell you. Right? And this is a pattern that comes up when we look at a lot of these things that I think you might want to express. So the other thing that comes up a lot is, particularly if you look at APIs that were created before Java 5, a lot of people used either integer values or strings where an enumeration would have been better. Right? And this creates an opportunity for lots of potential errors that are uncaught by the compiler. So for example, here is java.sql.connection. There's a method called createStatement, which takes a result set type, a result set concurrency, and a result set holdability. And all three of these parameters are declared to be of type int. And then there's a whole bunch of public static final ints declared. Right? So there's result set.type forward only, type scroll insensitive, type scroll sensitive. And then there's concurrent read only, concurrent updatable, and then cursors over commit or cursors at commit. And if when you invoke this method, you get the parameters in the wrong order, nobody complains, right? Because it's just 3 ints, right? And you just get weird, unexpected behavior. And so how are we going to fix that? So what we're actually going to do is we're going to allow the SQL people to define their own annotations. So they can just define an annotation as simply as this. This is all the code they would need to define 3 annotations. They define one called result set type, result set concurrency, and result set holdability. So this public at interface result set holdability declares result set holdability to be an annotation. And then I put an annotation on the annotation saying that this is a type qualifier. Then once I've defined these, then in SQL, I can go in and all those method parameters that are supposed to take a result set type, I put at result set type on the method parameters. And in the public static final ints that declare the constants, I declare those to be a result set type. And now I've sort of added an additional type system on top of the Java type system. And if you try to pass things in the wrong order, we'll want the tool to generate an error. Okay? And one of the important things is that 305 isn't going to declare a result set type. It's not within our scope, right? Rather, we're going to define the meta-annotation type qualifier, which will allow anybody to define their own type qualifiers, which can then be interpreted by the tools. Okay. So what I showed you before was sort of like the minimal type qualifier definition, which left out a lot of capabilities. Now I'm going to show you like a full-fledged type qualifier with a bunch of bells and whistles. And this might actually be how non-null looks. So we can tell, we can say that it's documented, right? Which means that it goes in the Java doc. We say it's a type qualifier. And then we can decide whether or not we want this type qualifier to be available through reflection or not. In this case, I said, make it available at reflection. And then I've defined an interface called non-null, sorry, an annotation called non-null. And then I've defined 2 elements of it, when and default for. And I'll be telling you what these 2 things do in just a moment. Okay? But so this is defining a type qualifier called non-null that's documented, available through reflection, and it's got these 2 attributes. So whenever you apply it, you can optionally provide these when values. Okay, the when element. This is one of the subtle and sort of deeper parts of it. So I'll try to slow down a little bit here. And if you don't understand this, please make me stop, right? Or at least slow down. Okay, so the when element is something that when you apply a type qualifier in a particular location, it allows you to describe the relationship between the values described by the type qualifier and what can actually occur at that location. Right? So in particular, we're going to do some little Venn diagram stuff. So we have a set of, so any type qualifier basically splits the universe in 2. It's values that have the property, values that don't have the property.
Runtime values?
This is, well, particular instances of it. Yeah, runtime values, I guess.
Okay.
Concrete values, I would say, rather than runtime. But okay. And then when we want to describe the values that can occur at a location, one of the things that I found was quite useful is it's really nice when you try to describe something is if you can try to describe not only your knowledge, but your imprecision in your knowledge. And so when we're going to allow a user to describe what values are possible at a particular location, he's going to describe what values are definitely possible at a location, what values are definitely impossible, and what are the values that we're not sure about. We're not sure about whether or not these values can occur at this location. We don't want to say anything. We don't want to mandate anything about whether or not these values can occur at this location. Hopefully this will become clear in a few slides. And it turns out that sometimes you don't know anything is definitely possible. We just know some values aren't possible. These things may be possible, but nothing is known to definitely be possible. OK, where's this leading? OK, so here's the win value. We've got the universe. Concrete values that have the property, concrete values that don't have the property. And win is an enum, and it has a couple different values. One is always. And always simply says that all the values that could possibly be in this location are contained within the set. Never, everything's outside it. Now there are some esoteric ones. And once again, I'd like better names. Maybe not, which means we know that there are definitely some values that can occur at this location that are outside the set. And there might be some values at this location that are inside the set, but we're not sure. Maybe either basically means we know that there's some values that can occur at this location that are outside the set, and we know there are some that can occur inside. Maybe yes means we know that there are some values that can occur at this location that are definitely inside the set, and maybe there are some values that are not in the set. And unknown basically means we don't know anything. And I can express these in logic rather than pictures, but I figure pictures was a more useful way to do it in this context. OK, so if we start out by defining a type qualifier non-null, then I mentioned I wanted to have this idea of saying null is feasible in this location. Well, that's simply non-null when, maybe not. Unknown nullness, I'm not going to say anything about whether or not a null value can appear here. That's non-null when equals when unknown. OK. So for non-null, we separate the universe into the non-null values and the one null value. So non-null is inside. Null feasible. Could be both, but we definitely know that a null value is possible here. And unknown nullness says we don't really know. We know nothing definitely about whether or not it's in one or the other. Okay. So there are a lot of win values, and they're not always useful. So like we could use non-null win equals win.never to locate a place where only null is possible. Right? So you could annotate that. It's not particularly useful. But on the other hand, one of the things I think, well, if you want to have annotations about nullness, what do you start with as your building block? Do you start with null, or do you start with non-null as your building block, and then build up the other things around it? And if you started with null, then you'd want null when equals never to reflect a value that's non-null. And you'd want null when equals maybe yes to represent null feasible. Let me give you another example, negative numbers. So once again, whenever you have one of these type qualifiers, you often find yourself saying, well, what's our building block? Well, let's assume we start with the building block of negative. Right? In that case, negative when equals win.never is non-negative. And non-negative when equals maybe either is signed. And so I'm showing that to you with the pictures, right? So we have non-negative we have the universe of negative values. Non-negative values are the ones that are definitely outside it. Signed, we know that this location can have values that are both negative and not negative. Unknown sign, we don't know anything definitively.
Quick question.
Yeah.
Can you have kind of aliases? So do I really have,
Can you have?
For annotations, do I really have, as a programmer, type non-null when equals
Okay.
Can I have
Yes. This turns out you don't want to have to type non-null when equals. So yes, I will propose nicknames for type qualifiers. Right. I mean, the thing is that this sort of situation came up, and I didn't really like the idea of just defining like 3 different qualifiers and saying that they're connected. And I like the idea of having one that you can put these different flavors on. But then you say you don't want to say it that whole way. Okay.
You have an example of one where, and you don't have to say what it is now, you have an example of one where maybe not and maybe yes or maybe.
Maybe yes and maybe no are both possible.
For one annotation.
No. Right. So a number of the win values are obscure and seem unlikely to be used. But they naturally fall out of the logic we want to express. And removing any of them would reduce the expressiveness and would force you into situations of, oh, well, I have to define negative as the primitive as opposed to defining non-null as the primitive. So it's possible we could reduce the scope, or it's sort of this trade-off. We could probably get by with fewer sets. It would reduce the expressivity. It's not clear it would really hurt. But on the other hand, maybe if we sort of declare them and just say, 98% of you don't need to worry about these other ones. And it gives other people the capability to build the annotations. And once again, I'm not keyed to the names.
Can you put these on branches, like the statements?
Well, you can't under Java 5. Right, so you can't under Java 5 because you can't put something on a branch. And the other thing is these are type qualifiers, so they have to be attached to a value. So you could have a branch, and in a branch you could declare a local variable on which you put the annotation. But, okay. Yeah, Neil.
I would suggest you call maybe yes.
Okay. So, and what do we actually do? What's the whole point of doing these type qualifiers? Right. And once again, names, they're in flux. But basically, what we want to do is we want to do a data flow analysis through the program. And if we can find a feasible path on which an always maybe yes or maybe either source flows to a never sync, then we want to generate a warning. And also the converse. If we see a never, maybe not, or maybe either source flows to an always sync, we want to generate a warning. And so in this context, if you talk about a method parameter, actually most things are sort of both sources and sinks. So like a field is a source when you read it and a sync when you write to it. A method parameter is a source inside the method, but it's a sync when you invoke the method. Okay. So, so that's how we check it. Now, like I said, you want to make it easy for people to do the simple things. And like I mentioned, for the result set concurrency. Sometimes you don't want to bother with all this win stuff at all. You just want to say, this is really a result set concurrency, and I don't want to muddle with all, win, maybe, all that sort of stuff. So when you define a type qualifier, if you don't give a win attribute, then you can't say when it occurs. And so basically, if you don't define a win attribute, then whenever you apply it, it's as though you said always. And also then, given the initial stuff, we would never generate a warning, because if we see always an unknown, we won't generate a warning. So in that case, if it's strict, if you haven't defined a win attribute, then if we see an unknown source flowing to an always sync, we'll generate a warning. Right? And that's basically how. So if you've defined these things, for these enum constants, if you pass anything, if you've got a method parameter which is annotated foobar, and foobar is a strict qualifier, then the only thing you can pass to it is something that's been labeled foobar. Okay. The default for element. All right. So and I'm going to get to a moment in terms of why I think we need defaults, but let me just explain the syntax of it for the moment. So unfortunately, due to some way of annotations work, you can't say like default for parameters and then pass it an arbitrary type qualifier as an argument. Right? So instead, what I'm going to suggest is that if you want in a class to say, I want all my method parameters to be non-null by default, what you do is you just put the annotation on the class, but then put in a parameter that says, no, this doesn't really apply here. I'm applying it as a default for parameters. And this can actually be a list of things you want to apply it to. Right? And so this just means that now within this method, and I'll get back to justifying it, if you see a method parameter and there's no explicit annotation, there's no inherited annotation, then it'll be treated as though it was marked as being a non-null parameter. Okay. So one other thing I haven't shown you yet is when you define a type qualifier, you can define a value element. And then, so if I've defined, here's the foo qualifier, which has a value attribute, this just allows you to define an entire family of type qualifiers. Foo1, foo2, foo3. And unless you do anything else, these are all orthogonal or independent. Whether something is a foo1 is independent of whether it's a foo2. And this doesn't look quite compelling yet. I'll come back to what makes it more compelling. So one of the things that you can do is you can actually say, I want a value that's exclusive. So one of the things, this actually happens inside FindBugs. At the source level, Java class names, the packages are separated with dots. At the JVM and in class files, they're separated with slashes. And in FindBugs, we deal with both. And if you pass a class name that's separated with slashes, someplace that expects a slash name with dots, it's bad. Right? And so I can define a type qualifier called class name that takes a value, which is a kind, either slashed or dotted. And thus, this defines two exclusive type qualifiers. They're exclusive because I put this attribute on the value. And what does it mean that they're exclusive? That means if something is always a slash class name, that means it is never a dotted class name. When brainstorming about possible things, we thought, well, should we also have exhaustive? Right? So if you had an exhaustive value, and in this case, it would only really make sense if the value was an enum, then if it was never red and never green, you would know it would have to be blue. I've not come up with a lot of compelling use cases for it, but it sort of seems natural. I'm not sold on this yet. Not particularly relevant or important. Although I'd be happy to have somebody come up with some good use cases for this. Sorry, what was the question?
Applicable to switch state with coverage analysis?
I mean, the thing is, I don't think you're going to be switching on enum types. Maybe. I mean, if nothing else, it's helpful sort of as a design decision. OK. So type qualifier nicknames. Question that's raised before. Nobody wants to be able to be typing at non-null win equals win dot maybe not all over the place. So my proposal is that you can define your own interface, whatever name you want, and you put an annotation on it saying it's a type qualifier nickname. Right? And then anything that looks like a type qualifier, which is applied to the annotation, essentially means apply it to wherever you want. In this case, I've also provided here the default for, which allows me to use this as a default. So basically, this just gives you a shorthand. It's sort of like type def, although whenever people hear type def, they groan, right? And there are a few subtleties to doing this, but we've generally found it to be useful. One of the other things that'll be really nice about it is that it will allow us to just go in and sort of retrofit some existing classes. So we add non-null annotations, and we can go into the non-null annotations that both FindBugs and IntelliJ have and say that they're a nickname for this kind of nullness type qualifier. And then they don't have to be treated specially by the tools. And we can also go in other places where people have defined their own annotations that have meanings like their type qualifiers and say, oh, this is a nickname for this kind of type qualifier. OK. Default and inherited type qualifiers.
Hang on a second.
Yep, sure. Sure.
What if you want the null feasible interface to be nullable, but you want it to be a qualifier nickname of maybe not?
You want it to be?
How do I say that the type null feasible may be null?
Okay, so generally we haven't, I mean, I've not come up with use cases where you actually put a type qualifier on a class because you want to say something about the class. Right. I mean, you know, I gotta say that there's been a substantial challenge in the fact that we're working within the existing Java 5 annotations, and there are all sorts of ways we could do this if we could change the language. Right? And you know, I'm not particularly keyed to this. If you can come up with a better suggestion for doing it, I'm happy. But generally, I've not come up with use cases. I mean, so I guess the case you're sort of talking about, and it is somewhat compelling, is to say, okay, I've got a class, and every time you see a field that has this class, I want it to be treated as non-null, right? You know, I mean, maybe we can find some other way to actually do that and so forth. I mean, there are a couple of other issues. The fact that for any particular annotation, we're allowing values for annotations, but you can only apply a particular annotation once at a location. You can't apply it twice with two different elements. So we have foo sub 1 and foo sub 2. You can't apply them both in the same location. There are all sorts of interesting challenges in terms of making this work. OK. So default and inherited type qualifiers. OK, so most parameters are non-null. Many return values in fields as well. There's been some discussion about this, but I believe that if you tell developers that you have to change the source and put in @non-null on top of every parameter that's expected to be non-null, that they won't do it. It'll make the source code ugly, hard to read. It will involve changing too many lines of code, which will require some vice president to sign off on how many lines of code you've changed. Maybe not at Google, but at some companies I know, that's how it would be. The other thing is that just say, oh, well, we're going to treat, if you have an annotated parameter, we're going to treat it as non-null throughout your entire 10 million line code base. Right? That's also not going to sell. And so what I think you want is to, and the most compelling use case is to say, OK, for a particular method, class, or package, I'm going to say that this thing has non-null parameters by default. Right? And if a parameter, so if a parameter doesn't have a nullness annotation, you climb outward, looking at the method and then the class. And if it's a nested or an inner class, you look at the outer class. And you climb all the way out, then you look at the package. And what I've actually found, I've done some of this actually using an earlier version of this we had in FindBugs, is what will often happen is you decide, you know what? Today I'm going to apply nullness annotations to this package. And you start by saying, this package has non-null annotations by default. And then you look at all the places where you get warning messages from your code, because there's some parameter where you are passing null, and null is OK. And then you go in and you say, oh, you know, in this place, null is allowed. Oh, this class handles a lot of nulls, and Joe wrote it, and I don't want to deal with it, so I'll just put in a class annotation of unknown nullness, because I don't want the package one to apply. And you just do several levels of iteration, and you get down to, you know, what you want. Right? So you can mark a package as having non-null parameters by default, and change that on a class or parameter basis as needed. Right? Once again, this is the proposed syntax that you just annotate the class or the package, or I guess method there'd be some problems with annotating the method due to multiple annotations of the same thing. But basically, if when you apply a type qualifier, it has a default for, then that says this type qualifier may not actually be intended for this element, but it's intended for all things that are contained within this that match whatever element type is said. OK. Inherited annotations. We also want to inherit type qualifiers. So for example, the equals method, I futzed on names, whether it's check for null or null feasible. Like I said, I can't decide on my names. But you want to inherit the fact that equals is supposed to handle null. You want to inherit the fact that compare to should never be passed a null value. Clone should never return a null value. Right? These are things you want to inherit without having to explicitly state them. So what happens, so if a parameter has an explicit annotation, then that's the one we're going to use in the analysis. There might be a separate check to see if that's compatible with inherited annotations. But if it has one, that's the one we'll use for the analysis. If there's not one, then we're going to look to see, do we inherit an annotation? Do we inherit a design decision for this method parameter, this method return value? If we do, we use that. If there is no inherited annotation available, then we're going to climb out lexically and look for a default annotation, a default type qualifier.
Question? Yeah.
Does that mean I could like override an equals method in the subclass saying non-null is not, sorry, I can change the nullness of that equals method in the subclass?
All right, so the question is could you change the nullness parameter for an equals method, right? The way I'm proposing, well, I mean, first off, you can do whatever you want. JSR-305 won't forbid it because we don't really say how your tool has to interpret these, right? But what I would recommend, and there's a little bit of a suggestion. What FindBugs will do is that in terms of analyzing this method, we will treat it as being non-null. But on the other hand, we will also separately generate a warning saying, you have annotated this method with something that is not compatible with the method it overrides. Sound reasonable? Okay. So it's really clear that we need to do something for nullness in terms of default annotations. Absolutely clear, right? It is not as compelling that we have to make this available for all type qualifiers, right? But maybe that's just because I haven't thought about it enough. I don't know. You could try to argue that, well, we need to do this for nullness, but it doesn't need to be general. I don't know. I like to provide general capabilities because somebody smarter than me will come up with some way to use this in some way I hadn't thought of. On the other hand, maybe somebody will come up with some really confusing way to use it that I hadn't thought of. And of course, having IDEs be able to interpret the default annotations and the inherited annotations would be great, so that when you mouse over a method parameter, it could tell you or display in some way that this is a non-null attribute. We use color coding or something like that to interpret all these. Because the fact that in order to figure out whether or not some parameter is non-null, you might need to look in here, and if there's not a default annotation there, go look in the package. That is unfortunate. And I think it would be a great place for tools to help people navigate this stuff. Yes, question?
So you said that you made a quick reference to the fact that for, you have to put the default for on the annotation. And you, instead of having at default for class and then say not null. Right. But I don't understand why.
Okay, the reason, so the question is, why can't you say, at default for parameters as an annotation, and as a parameter, you supply it with non-null. Yeah. The reason you can't is that under Java 5, when you define an annotation, the elements of that, if it takes an annotation as a parameter, it has to be a specific annotation. So I could define a annotation that took a nullness annotation as a parameter. But I can't define an annotation that takes as a parameter an arbitrary annotation. Now, I've got a proposal to change that for Java 7.
Because I think that the default for thing having to be repurposing the annotation types to also provide default things makes everything much more confusing. And
yeah,
it's not worth retrofitting that on.
I'm not, if I could pass an arbitrary, if I could define an annotation which took an arbitrary annotation as a parameter, I would be using that. And perhaps we will actually deprecate this way of doing it once, if you're in Java 7, and provide a different way of doing it. But the problem is it's a limitation of the annotations in Java 5. Okay, so if you guys haven't ripped into me yet, here's some new meat. So one of the things I'd like to do is to allow you, when you define a type qualifier, to define a validator. So a validator is, and I think typically we can just do this by using a design pattern where you put a static inner class to an annotation. I didn't know you could put a static inner class in an annotation, but you can. And what this is it's a class that can check to see if a particular concrete value is an instance of the values, if it's in that set. Right? And then if you've got a static analysis tool, the static analysis tool can actually take the annotation libraries, load them, and execute them within the static analyzer at static analysis time, and check to see if this constant value is actually an instance of it. So for example, I talked about having an annotation for slashed class name or dotted class name. Right? I could write a validator that checks that. And if I see a constant value being passed to a place where a slash class name is being used, we could do a check at compile time to figure out if that is indeed a slash class name.
So presumably these methods would take the tree APIs.
Actually, so what I'm proposing for these is that it's not actually going to do any walking over the syntax tree. That all it will do is simply say, here's an annotation, here's an instance, like a constant value. Tell me, like a string value. Tell me whether or not it's an instance of it.
So it only works for constants.
At static analysis time, it will only work for constants. You could also define this thing to allow tools that would walk over abstract syntax tree. I think that's getting too complicated.
So don't you want new foobies to be a non-null foobie?
Non-null foobies. I think we may need to take that into later discussion. So like I said, at static analysis time, we're at least in theory only going to do this for constant values. You could actually do some abstract interpretation to try to figure out stuff, but let's not go there. You could also imagine dynamic instrumentation, right? So if I put in stuff for slash class name and dot class names, you could imagine, not with Java-C, because Java-C, we're not allowed to change the semantics, but you could imagine a tool that would do bytecode rewriting. So at every place you had a method parameter that was declared as taking a slash class name, it would insert instrumentation to call the validator and check to see if what is being passed to this parameter is indeed a slash class name. You could imagine a tool that would actually insert instrumentation to check whether or not all the method parameters that were declared as non-null were indeed non-null. And this actually overlaps some with the validators with JSR-305, which is also defining a set of sort of annotations with validators that's more designed for stuff like interfacing with databases and so forth. Right? And here's an example, which is too small, but so this is a credit card number annotation. And you could define a validator that actually checks that it matches the right regular expression and performs the Lund verification, right, to verify that this is indeed a valid credit card number. And one of the other things, I mentioned that type qualifiers have this value attribute, right? So when you call the validator, you actually pass in the actual annotation, right? And so the thing is, the actual annotation has a value, right? And so if you had foo of 1, foo of 2, foo of 3, then when you call the validator, it would know whether this is a foo of 1 or a foo of 2 or a foo of 3, and it would be able to check things separately based on that. Okay. This is a little bit, we're not as far along with our implementation here. This is a little bit more out there, but I think this will be a really interesting way for people to do some things, particularly when I talked to people at Agitar and so forth, and they were very interested in not only things like validators, but generating factories to help them generate test cases. So if you have credit card number on something, then if you defined a validator for it, if you defined a factory for it, then you would have a tool that would automatically generate credit card numbers that you could try to pass to that method to generate unit tests. And so there are all sorts of things you could do in terms of, and the nice thing is you don't want to do this in terms of JSR-305 defines the credit card number annotation. The thing is, can you do the meta-annotations, the design patterns that allow tools to do this? All right, so do we need a way to cast? So, how do we force the analysis to assume that the result returned by a method is a credit card number, even if it can't prove it? Perhaps because we've done some sort of validation. I'm not entirely, one way to do it is to have another win value called assume always, which says, I don't care how you put stuff into it. So if you had a method that was annotated, its return value was credit card, assume always, then anybody who invokes that method would assume that the result is always a credit card number. But within the method, you could return anything you want because you said assume. OK. So I have a little bit of time talk, So
You can run over.
Yeah, so I can run a little bit over. So now I've sort of given you the general framework. Let me just give you a couple of the concrete type qualifiers that I think we might actually define as standard. So one is untainted and tainted. Right? This is one of the places where you definitely need a cast because you will have cleansing methods that take tainted values and return untainted values. And you'll want to have some way to make, to say that, OK, well, I computed this from an untainted value, but I now know, from a tainted value, but I now know that it's untainted. And hopefully you guys know all about SQL injection and nasty stuff like that. So those syntax, one of the things that's been proposed, and IntelliJ has some features like this, is to say, what goes here should have the syntax of a regular expression. If the string you pass me here is not a valid regular expression, I want a warning to be generated. Right? Or this parameter should take a string, which is Java syntax. Or this parameter should take a string, which is SQL syntax. Now, of course, there's more than one SQL syntax, unfortunately, but in spirit. Right? And then this could be used both statically, dynamically, and so forth. And also, the other thing that might be nice is IDEs might be able to do some refactoring support here. Right? That if you mention something has Java syntax or SQL syntax, that could help tools do better things in terms of refactoring. Pattern, although we probably won't actually use pattern because it's a name collision. But it'd be nice to just have an annotation that says what goes here must match. It should be a string value that matches a particular regular expression. So this would say what goes here has to be a string of digits. OK. So that's type qualifiers. Right. So let me see if there are briefly any questions, type qualifiers, then I'll talk about a couple of the additional annotations I'd like to be able to provide. So we've got plenty of time for discussion afterwards. Yeah, question?
So how do you propagate type qualifiers? Like if I write a method which looks up something, gets a string out of a structure, do I mark it tainted or untainted? I want the taintedness to propagate. I don't want it.
So the question is, in general, for type qualifiers, is if you see an arbitrary computation, is there some sort of way to figure out what type qualifier applies to the result of this computation based on the type qualifiers of the values used to compute it?
Or specify the relationship.
Right, specify that relation in some way. So for taint, if anything tainted is used to compute something, you're going to assume the result is untainted. Non-negative, the rules for whether or not the result of an arithmetic computation is non-negative based on the sign of the arguments can get kind of complicated, right? I think we may just go one or two simple ones. Either it's contagious or it's not contagious. Right, so if it's contagious, that means if it's tainted, taint propagates. If it's uncontagious, that means if you see a computation you don't understand, you just assume that it's unknown.
How do you specify it?
I mean, how do I specify whether it's contagious or not?
No, how do you specify? I define some routine. You don't know what it does.
Right.
But I want to specify that it propagates from parameter to the result or.
Yeah, so I mean, so for example, one question is how do you specify something which is polymorphic in a type qualifier?
Yeah, which is
like the identity function.
Right, like the identity function.
Which is going to be the usual case for libraries.
Right. So taint is going. I mean, so at the moment we're not planning to address that. Right. I mean, in some ways, shoehorning taint into here is sort of complicated because all these rules about polymorphism and so forth. I don't think figuring out how to do polymorphism over type qualifiers, I don't think that's well enough solved that we can propose to implement it in 305.
This is very important. Maybe taint is not frequently enough used
that it's important.
It applies to all the type qualifiers. You gave examples of it. It applies to the patterns ones.
Well, the thing is, it's like for nullness, right? The tool will do its own analysis based on what it knows about nullness in procedures and if statements and how instance of works to propagate nullness through that's not dependent upon type qualifiers. What I'm not sure we want to do, I mean, there has been some work on this. I don't think it's ready for 305 that allows you to define, okay, for my type qualifier, I want to give you an abstract interpretation that tells you how to compute the results based on that. I don't think we want to do that in 305. I think even getting what I've got in is getting all the cats herded is going to be a challenge. And I'd rather not try to define an abstract interpretation that takes the abstract syntax tree or anything like that.
This is not about abstract interpretation. That's a different issue. This is about being able to declare an interface which describes.
Yeah, but I mean, like I said, you would also want to be able to define in a similar way how to compute whether or not the result of an arithmetic operation is non-negative or not based on the sign of the parameters.
Well, that's something else. I mean, you want to be able to say that if A is null, then if the else branch, you know that A is not null.
Right. So I don't think that we can shoehorn that into 305. I think various tools will do that. But this is not saying tools. What?
How can they without looking at the source code of the libraries you're calling?
They will. I think given the number of people who are disappearing, I'd like to move on and discuss a few more things, and we can discuss this after the talk. Okay? Okay. So thread and concurrency annotations. So the Java concurrency in practice had a couple of standard annotations. Thread safe, not thread safe, immutable, and guarded by, which basically allows you to say that this field is this is what locks you should acquire in order to touch this field, right? And we're looking, and my only sort of concern about that is I haven't thought real deeply about these. I think what somebody really needs to do is apply them to a large chunk of code before we'd be really happy with them. But they're the best we've got at the moment, and we'll probably include something like them. What's wrong with this code? Well, it's hard to see, but the problem is it doesn't close the file. And so one of the little subtle details that actually isn't even documented well in the Java doc is that properties.load does not close the input stream that's passed to it. And so we'll probably have annotations, or current suggestion, have annotations will not close, will close, or will close when closed, right? So
on the field?
You would typically these would typically be on a method parameter, right? Simply say, if you invoke this method, is this method going to close the object? And the only one which is a little subtle is this one would typically be used for factories or constructors. And it would say that when you close the object that's returned, then whatever you were passed in will be closed. We're almost going to get close to our time. So two more that I found really useful: check return value and injection annotation. So check return value indicates a method that should always be invoked as a function, not a procedure. There are a whole bunch of these in the JDK. For example, string.to lowercase. If you see a statement, s.to lowercase, open paren, close paren, it's almost certainly wrong. They're thinking that that's going to modify the string it's invoked on, but it doesn't. Because strings are immutable, it returns a new one.
Get class in that category?
That one has effects, right? Well, actually, sorry, not get class. I was thinking of class.4name. Get class.
Its only effect is a null check.
Yeah. Actually, I would put it in that check. I mean, I have actually seen code that will, for example, get the length of a string as a shortcut for asserting that the string's not null, right?
You'll find get class all over the code generated by JavaC.
Okay.
Null check. That's the idiom JavaC uses for a null check.
Okay. So at any rate, but this will. So we've already done this. We've basically gone through the JDK and come up with a bunch of methods that if you invoke them like this, it's a problem. And the main thing is we want to allow people to do this in their own APIs. We want to allow people at Google to put this on APIs within the Google code base. Says if you invoke this method, you better look at the return value. We've thought about things like idempotent and things like that, and I think those are more complex than simply saying, if you invoke this method, look at the return type. Injection annotation. So static analyzers get confused if there's a field or method that's accessed via reflection or injection. They don't understand that that can happen. And a lot of frameworks have their own annotations that they've defined that indicate that the framework should do some sort of injection on this field. And so what we're going to do is we're going to define a meta-annotation. So we'll define injection annotation. And if you put injection annotation on an annotation you define called X, then wherever you use X, the static analyzers will understand, oh, this thing is going to be manipulated through some way I don't see in the source code. OK. So over the past 6 weeks, Dave Hovermeyer and I have largely implemented what's described here for type qualifiers, mostly Dave. We still need to work on the validators and the type qualifiers with exclusive and exhaustive values. But other than that, the basic type qualifier stuff is done. We haven't done like will close, must close, will close, won't close stuff. And I'm now actually about ready to wrap up. So generic wrap-up slide. Static analysis is effective at finding bad code. One of the questions is bad code found by static analysis an important problem? Getting the static analysis into the software development process, big problems. It's been worked on here. And annotations will be helpful. And I think the two things. One, we got to get developers to use them. And the other thing I think is that coming up with a way that we can enable developers to express the design properties, the special type qualifiers in their code base will make it far more useful than if we come up with a JSR that's restricted to expressing 5 or 6 or 8 or 12 concepts that we could squeeze into the JSR. At that point, I'm out of slides. And Dave, I actually got through like 70 slides in an hour.
And 66 slides in 66 minutes.
Yep. All right. So, any brief questions at this point? Move downstairs. OK, thank you.